Hello, welcome back to Matrices LIVENODING. In this episode, I'm gonna touch again on the multi-extrude. It's part of extrude region nodes. This nodes. It's actually supposed to be quite simple if you use it, but there's a gotcha that I found. Actually, I shouldn't start with this. This is I call this Babushka because this guy looks like a grandmother in Russia. If you look at it from profile, looks a little bit like that. But anyway, I'll probably start from scratch. I will save this one. Okay, I'll just start from scratch, and I'll have just a plain viewer draw and extrude region. This guy have multiple extrude, and I quite like the multi extrude. This actually have a lot of potential if you do a lot of procedural like a modeling. Extrude is actually very powerful. We don't have like extrude along path or something like that, but maybe in the future, some in the near future. So hopefully, so anyway, if I start from a plane like this, and then I'm doing extrusion. Let me try. This guy, multiple extrude actually require you to have matrix, like a list of matrices, and this is the one that's actually kind of tricky sometimes. I'll save it. So this is SV extrude multi revisit. And the way to make sense of this is if you are using something like a list input, and for this guy, for example, the locations, we're gonna use vector. So vector, okay, 0 0 0, we got nothing, and then if we increase it, okay, so location kind of place the matrix for your extrusion. So that's kind of makes sense. Okay, let's zero this out, just keep the Z. So let's have, if we have like a bunch of extrusion, so that's the second extrusion, you see right away we can have something pretty cool, you know, like an objects with multiple extrusion, all with different distance. This is really cool actually, and you can model a lot of objects simply by using extrusion. And if you think like all the modular part of a table, or maybe or an insect or animals, the torso or the legs, they all can be built using extrusion if you can control the rotation, scale, and everything, you know. Let's say okay, we are happy with this location, so seems like the effects also kind of accumulative. Let's try on the scale. Right away we get an error because scale apparently doesn't like 0, so be careful with that. I'll show you what I mean. So list input vector, plug this into the scale, we get error. Let's make 4. So it still doesn't like it. Let's have it like this. Now it's not complaining anymore. So scale is slightly trickier. Normally instead of using this, I'd rather use a float, and I use vector input like this. This is much simpler. You're only working with a single value, plug into the scale. And now let's try. It doesn't like 0 scaling, so that's the thing. So I'll make this all 1, and I'll start from, okay, I'm zeroing the first matrix, and I'm scaling the second one, makes the next one smaller and the next one bigger. So right away you can get this kind of design, but you can see right away it looks a little bit funny. Yeah, this is the thing, this is a gotcha, you know. Apparently the extrude region, multiple extrude is really only good if you're extruding from the center. If I center it out, you know, if I center the original plane, now it looks a little bit more correct. Scale kind of also being influenced by the position of the plane. Let's say if I move this plane and use vector in and move it to the side, you can see the scale doesn't go with it. So that's also like, okay, that's kind of the limitation I found. I don't know what's the solution yet, but we can always use a matrix and place our objects this way. See, we can always move the objects. Imagine if you are designing something at the 000 position, and then you want to have like a multiple kind of duplicates, you can do it this way. So that's no problem. And you can also randomize the objects like this if you want. Like randomize the scale maybe and whatnot. Anyhow, let's move on. So location, scale. Scale is actually something that's a little bit funny. Rotations, everything else is actually quite easy to understand. By default, rotation is 001. And if you rotate it, you know, it's gonna spin. It's gonna twist. And if you change it to X1 or something, you can kind of rotate it. Actually 1, 0, 0. So this is going to be rotating in the x-axis. You look at this x red color axis. It's going to rotate that way, and then that's going to do it for one of the matrix. So 45 degrees. This is the 45 degree that you get, and then you can rotate the next one if you like. So again, you're gonna do something like this. Let's zero this out. The first one 45. Second one minus 45 maybe, and you get that kind of rotations. It's pretty easy to understand. And if you want to extrude again, kind of try doing it from here first. It's not always, it can be tricky, but you know, it's quite makes sense. So now this guy is looking like the Russian Babushka, the grandma. Again, I just open the one that I have. I'll delete the text and look at this one. In this one, it's almost like I'm using the adaptive polygon. I'm trying to make sense of this extrusion stuff. Let me try. So with the extrude region, I have this Babushka. If I kind of imagine if I have like this plane, for example, I'll delete everything and I'll have a bunch of plane, for example. Zero it out. I'm scaling it a little bit, and I'll move it up a few times. So 1, 2, 3, 4, and I'm using objects in, get selection, and I'm using the matrix for our extrusion. And you see what's going on. This guy have the effects on the extrusion, even though the effects pretty extreme, because for each one of them I have a scaling going on. So yeah, this makes a little bit more sense, I think. So this is the first extrusion, I'm scaling it, I can push it up. And the second one, if you look at it, 0, 0, 0 is putting that object at the bottom, and I'm scaling it and I'm moving it up. I can even rotate it, you know, like animate this guy like that. And plane number 2, this is the next extrusion. I can scale it down maybe. And the last one, I can also scale it down again. But the effects seems to be accumulative, so be careful with that. Again, yeah, this is slightly tricky, but still can be pretty useful. Who knows, maybe this node will change again in the future. What would be nice is if this guy behaving more like a joint, like a bone, for example. I imagine if the bones this is the first one and the second one, and they're kind of related, and then they have like a child-parent relationship. So the first plane, second one, first if you rotate the first one or scale the first one, the second one will scale as well, and then so it makes more sense, kind of to think of this matrix like that. So that's if you are using the matrix of plane to do the extrusion. The next one I want to show you is if we go back to our Babushka and then kind of use it to we're gonna use this box, and then we have this center polygon and calculate normals. The matrix looks like something like this guy right here. If I scale the box, you can see the matrix doesn't change in scale, but the position change. But we can see clearly the rotation axis, etc. And we can plug this into the, not this guy, yeah, not this guy, but this guy. That's our Babushka. So the Babushka being instance on the box now. Yeah, so this is pretty interesting. So in fact, the nice thing about this is that if we have like multiple variations of the Babushka, we can then have some kind of design very quickly, and it's not like more or less like a tentacle, for example, or some other creatures. This is how you can start thinking about the modular part of an object. So when you're designing, normally if you make a table, for example, you will probably, okay, you do like a split there, and then you just do an extrusion. But I think with a parametric design, you actually think everything as a modular part. So you start designing the leg, and then you copy the legs into 4 parts. If you are designing a creatures and you want to have legs, you design the legs separately maybe, and then you plug the legs into this position, and yeah, that's kind of new for me. It's kind of like a, sometimes you think of it, it's like kind of like a the opposite way of working. So you start with the smallest part and then you grow up higher, but you always think about how they're gonna be put together. Yeah, so in this case, the Babushka thing, I can just, for example, randomize the box, randomize this guy, and right away we're gonna get a different result. I don't know, the Babushka is kind of dancing on top of the box, it seems. Yeah, but anyway, this is like a quick look again at the extrude region. This extrude region can be very powerful if you do a lot of extrusions. And remember, you can always go back and see. In this case, I make the Babushka a little bit higher in resolution. Yeah, you can always go back, and make changes to all this. Change the radius. You can even animate it. I forgot that we can animate it. So with the Babushka, I think I have control over the rotation, so you can make the Babushka kind of doing, like a bowing, hello, and then move the head and move the nose a little bit. The funny thing is that you can also use matrix deform and then rotate the Babushka. It's like very simple rotation of the head, because they have these matrix in and matrix deform have different rotations. So this one is 100, this one is 001. Yeah, I think that's pretty much it. Slightly complicated, but slightly also a little bit funny. But hopefully you enjoyed this one. Let me know what you think, and hopefully in the future we're gonna cover more of this extrude region, especially with multiple extrude options. Yeah, thanks again for tuning in. I'll see you in the next video.